Today we're going to be talking about the future of AI and the promising approaches. We're going to have three speakers. So let me welcome them first to talk about the future of AI. I guess we have several subjects we could be talking about. I think being French, we have a lot of things about theory, and we like theory a bit much. And to a certain extent, what we've seen in deep learning is the rise of empirical findings, and the fact that one of the reasons we're here is mostly because deep learning has essentially changed a bit the face of machine learning and so forth. I'd like to have some idea from one of you, the three of you, on what you think the theory can bring back to the whole area of AI in the coming month, year. Why don't you start, Francis?
Yeah, indeed, this is like very empirical, and I think clearly for my taste, it's much too empirical, and I think that it works very well, deep learning indeed, once you have the correct architecture, correct number of layers, correct number of hidden units, and so on. It's totally true. It works. It's super robust. Okay, I'm sure many of you here have trained their own AxelNet, ResNet, or whatever. But when you go beyond this, okay, when you need to define a new architecture for a new problem, then this becomes much more difficult. And this is very empirical and also very demanding in terms of resources, computational resources. You need like to burn. You need to burn like several forests to be able to define any new model, and I believe this is not acceptable. Okay, and I think to me, theory should be there to provide guidance on the design of such architecture, but it's still not there yet. There is some rules of thumb, but I don't see clear good theory about this, and I think it's needed to help design new architectures.
Do you have any thoughts, Olivier, on this?
So yeah, I completely agree that it would be very useful to have some way to automatically define the architecture based on a problem, or maybe on first cheap experiments that you run on your data, and based on the results plus theory, a way to design the best provable architecture for a single problem. I think another application where theory could be useful is security. When you deploy computer vision algorithms, you might want to be able to prove that it's not subject to be attacked to adversarial examples, for instance. I think that's another area of research where theory could provide something like safety guarantees, basically.
Bernard, do you have any thoughts on this?
I agree completely. We used to tell that deep learning is a way to avoid looking for features anymore, because deep learning is able to discover features, but you still need to provide a good architecture for the entire model, which means that we have replaced one problem by another one, which is at least of the same complication, and in fact more. So anything we could do in order to improve this part of the game would be very useful.
Okay, great. I've got many other subject areas, but if there is one that you want to talk about more expertly, I welcome your input on this. There is this other aspect. There is the social aspect of AI that is essentially one of the reasons we're talking here, where there is a lot of demand from the social society on essentially expectations with regard to interpretability of AI algorithm and so forth. Yeah, okay. I'm sorry, I'm not close enough to the microphone. So my question to you guys is, where do you see this field of interpreting algorithm of AI coming up? If it's coming up, are there any leads on how to make this faster, better, and so forth? Olivier?
So yeah, basically the trend that we can observe is the more complex a model is, the best accuracy you can get if you have enough labeled data. But on the other side, you can no longer try to mathematically describe exactly why this decision was made, or it's blurry. And so if the model exhibits a bad behavior, it's hard to prove what is the cause. I think maybe it's not necessary to find ways to interpret models, but it might be easier to build statistical procedures to assert that a specific model does not have a bad behavior, like exhibit a racist behavior, for instance. So maybe it would be possible to do from the outside, to treat the model as a black box, to train it once and make it as performant as possible, and try to prove from the outside that this model does not exhibit a bad behavior without trying to restrict the model to be linear, for instance, or any other constraint that you might think of. I don't know if you have other ideas.
What about you, Francis? What are your thoughts on this?
So I think this is a very old question. Like having models which you can interpret has been around for the last 40 years. And this was true for decision trees. It's often considered better than like SVMs or kernel or neural network because you can interpret. It can be much worse in terms of performance, but you can really see what it does. And this was the case 20 years ago, and those issues remain the same. So as let's say, imagine you're a patient, your doctor, and the doctor tells you, I'm going to advise surgery because that machine told me so. You want maybe a bit more, okay? And for many areas like medical diagnosis and anything medical, you need that interpretability. And since this is old questions, there are also old answers. And one topic I've worked a lot on is the topic of sparsity. So you want to find the smallest number of variables being able to explain your prediction. So this is not super fashionable right now, but if we were to do like the same meeting 5 years ago or 10 years ago, it would have been on compressed sensing. And I think those ideas are still very relevant. Okay, so finding a way to select the good variables which are sufficient to do a good prediction, potentially at the expense of predicting a bit worse, is still very, very important.
Do you have any thoughts, Bernard?
I think this is still a very important research topic on which there are still lots of things to do. I agree on the fact that we need to do some trade-off between the quality and the precision of the model itself and the fact that you are able or not to interpret it. Using a model as a black box is, I think, a very useful tool in order to understand if there are some bias in either the data itself or in the algorithm and the way it has been trained. But honestly, there are still a lot of things to do. So I understand the concerns, the societal concern, but at the same time, there are still a lot of things to do. So we perhaps want to produce some kind of legislation on algorithms and the fact that we need to find a way to interpret the way the decision has been taken, but at the same time, there are things that we cannot do yet, and we need to understand that.
Okay, let me rewind on that constraint in the first place. Does any one of you believe that putting constraints that are guaranteed by law are actually changing the face of some algorithm, machine learning or AI-related type of algorithm? Do you think that there is a need for constraints to actually have better models, or those constraints are premature in terms of optimization?
So I'll be very clear. I think AI does not need constraints. AI users do need constraints. And I think it's not a constraint of the model, it's a constraint of the people using the models. And I don't see any law being interacting with an algorithm. I don't see why it should be the case. But forcing users to be careful, this is like, for example, there's a study done at Stanford like a few months ago on predicting sexual orientation from images. This is insane, okay? And so shame on those researchers. And we should not forbid like some predictions. We should simply like make sure that researchers doing bad things with their research, like in all disciplines, should be, I would not say punished, but should be, punished. Okay.
Yes, I remember research paper published by Microsoft Research in Cambridge about using Facebook likes on predicting potentially your sex, your sexual orientation, potentially the party for which you vote, and so on and so forth. So it was very, very, very well predicted, but at the end of the day, it represents a big, big threat on all of us. So in some way, there should be some kind of regulation, but put in such a way that it doesn't prohibit innovation, which is potentially very tricky, especially everything related to privacy, which I think is a very hot topic those days.
What about you, Olivier?
There is another application of recent machine learning developments that could be problematic in the future is the new ability of generative models to be able to imitate humans and to be used as very efficient phishing tools at a very wide scale. For instance, like Google yesterday deployed in the Google Assistant synthetic voice that is very, very human-like. Like, it's very hard to tell that it's a robot voice. And if you have a human voice, then you can do spam on the phone that is very convincing, that imitates people that you know, because there might be recording of their voice. So I think this kind of applications of machine learning, where you try to imitate someone to deceive someone else, can be very, very problematic. And I think for this kind of thing, we should start to think about regulations, not to deploy models that try to impersonate real human beings for anything.
So when I was asking the question in the first place, it was more along the lines of, are there regulations that essentially stop the algorithm to essentially have degrees of freedom? But soon enough, the discussion that we're having is, oh, there are bad researchers or there are bad research areas somehow, and we need to somehow regulate this. That kind of slipped in a fast fashion from regulation on the algorithm to regulation on the people that are actually coming up with those things.
I don't think there is bad research areas. It's really bad applications of results of research that can be very problematic. And I think it's more like these new tools, technologies can give a lot of power in the hands of very few people. And this is what is problematic. The same for weapons. Or whenever you give a lot of destructive power to a small number of people, you have an issue. And so you should start to think about it, how to control this.
Any other thoughts on this?
To me, I think like AI or machine learning is not different from other disciplines. Like physics is full of problems like that, and we have dealt with those in the past, and we could deal with them in a similar way for AI.
It's a very old problem, in fact. If you look at the Greek literature, they told about pharmakon, which is basically the fact that a medicine could be good or bad, the same one. So it's almost the same.
Okay, I didn't think we would be slipping through to these very dark areas so fast, but okay, let me try to be more inspirational because we have only 5 minutes left. Are there any, in whatever you've seen, and you've seen many things, are there any areas, applications or research areas that you really want to talk about because you know that not many people know about it, or you think that it should be known by everybody?
I can start by addressing 2 different topics. The first one is security and privacy. I think there are new ways to do machine learning in a way that you could potentially share medical record, as an example, between various stakeholders, and at the same time not sharing the identity nor sharing the contents of the data for each of the different parties. So this kind of technology could rely on some new advances in hardware, especially, where there has been defined by Intel and others some extension to their architecture in order to create what they call enclave, where potentially you can encrypt data and code in order to enter into a processor and make sure that only the processor, using a set of keys that comes directly from the various party, could decrypt the content, and the output and the end result is also produced by the processor encrypted, which means that anything, including the code, not only the data, because the code is also very important, is encrypted, and only the processor is able to see it. So this is a topic on which we are currently working. We have some prototypes running, and we have good hope it will help to solve this privacy problem.
You have had some time to think about inspirational ideas, research,
yes,
applications.
So we follow like Bernard and also talk about what we do in the lab, which is like weekly supervised learning. So we hear a lot of things about most applications are totally supervised. You need to provide like pairs of inputs, outputs, and the next frontier is unsupervised. I totally disagree because totally fully non-supervised is impossible by design, but even humans, we have some weak supervision. And taking advantage of that weak supervision, to me, is key to leverage the huge amounts of data that people have, which are not fully labeled, but partially labeled. So to me, I think this is really something that few people work on, and this is where, to me, all the benefits will lie.
I think, yes, this finding new ways to extract cheap labels at scale is very promising, and also trying to combine several tasks in a single model. For instance, if you have visual data, images, and text describing with a data set that joins them together, to be able to have a model that combines the two so that it works better on individual tasks. That's interesting because that moves us into the direction of having more and more general models, so to generalize better, but also to go into the direction of a general artificial intelligence. It's a long way to go, but I think that's also interesting. And another development that I find intriguing since a couple of years in the deep learning literature is the fact that stuff that we there are reasoning tasks that used to be very symbolic in the past, and that now we can find end-to-end way to do with gradient descent. So it's a bit the opposite of what François Chollet told before. But for instance, the attentional mechanisms combined with differentiable layers like relation networks can be useful to answer questions on visual images that require some kind of reasoning. And to me, it's very amazing that we can do it just from examples. So I would really like to know how it's going to evolve in the future, how much we can reach by doing gradient descent, whether we can do a high-level reasoning task, high-level cognitive task, just by seeing examples and train a model to reason from data, basically.
Okay. Any last words? We've got 40 seconds on this topic of the future of AI, which may not be just machine learning or any of the things that you've been working on, but more like brain-inspired or any of these things that are coming from a different world that are essentially dripping down into the field nowadays.
I think the brain inspiration, yeah, sure, we should take like examples from things that work, but it's not the only way to go. So there's been many examples where non-natural things can be made to work with engineering. So I think it's the same for AI.
What about you, Bernard? We have more time, actually.
Time is added. Yes. Okay, so I'm going to stay focused on machine learning. I was mentioning this morning the coming role of quantum computing on the field of AI, and I think there are some very interesting things that are currently happening in the research, especially around Boltzmann machine because we believe that that's a good way to use quantum computing because it's linear model rather than non-linear model that are used in deep learning usually, which means that you can use quantum computing mathematics very efficiently in such an environment. So I think that's very promising.
Okay. What about you, Olivier?
I don't know actually.
Applications could be another area.
So something that is really exciting is the amount of collaboration that we see among software developers and tool developers, and the way open source has enabled the transfer from very state-of-the-art results from the academic community to application domains in startups and larger companies. So I think that's kind of unexpected to, like, it used to be the case that one would accuse academic researcher to work on things that were useless. And I don't know why in this field, like maybe open source has like channeled in a very large bandwidth a lot of new innovations to many kinds of applications that were kind of unexpected a couple of years ago. So I don't know if it's gonna keep on going this at this pace in the future, but I find it very exciting.
Okay. All right. Great. Well, thank you very much.